microplastic.
Microplastic. Microscopic particles getting inside our bodies, found in almost every organ in the body.
Microplastics in the brain was equivalent to the weight of a plastic spoon.
Okay, so at this point, you probably know that microplastics are polluting our oceans and contaminating our food. But what you may not know is microplastics are no longer just an environmental issue. They are now a human health issue. These tiny particles have already entered the food chain, the water we drink, the air we breathe, and now microplastics have entered virtually every compartment of the human body. They've been detected in blood, lungs, liver, gut, heart tissue, breast milk, and even the brain. And science is beginning to reveal what they might be doing while they're there. So in this video, let's dive into the discussion on microplastics and our health. What they are, where they come from, how they get in, and what happens next. Microplastics are tiny plastic particles less than 5 millimeters across, most even smaller than a grain of salt. Some are created intentionally, like microbeads in cosmetics. Others form from the breakdown of larger plastic wastes, such as bottles, tires, packaging, textiles, and so on. These particles have become an unavoidable pollutant, and as plastic production only continues to rise, so does our exposure. Microplastics enter our bodies primarily through ingestion, inhalation, and to a lesser extent, skin contact. We ingest them through contaminated food and water. We inhale them as airborne fibers, especially indoors where dust from clothing, carpets, upholstery constantly shed microplastics into the air we breathe. And emerging research now suggests that some may even enter through skin contact, especially during workouts if we're wearing tight synthetic clothes like polyester or nylon, which can shed particles through friction, heat, and sweat into our open pores. The concern is not only that we're constantly exposed, which we are, but according to new studies that these particles accumulate in the body, potentially over a lifetime. Once microplastics are deep in your body, it's pretty much a dead end. Yes, some bigger particles get excreted with urine or stool, but not all. Because of their teeny tiny size, microplastics can cross even our most protected biological barriers, slipping through the gut lining, entering the bloodstream, and even passing through the blood-brain barrier. Okay, so why is that an issue? Well, because contrary to popular belief, once microplastics are lodged inside our tissues, they don't just sit quietly. For a long time, it was believed that microplastics were benign. Foreign substances, yes, but functionally harmless. Too small to notice, too passive to cause any real damage. But as I've come to learn, that no longer is the case. As it turns out, microplastics are not biologically inert. They interact with our biology at a chemical, cellular, and systemic level, and we're only beginning to understand the consequences. Microplastics pose both physical and chemical hazards. Physically, these foreign particles can damage or inflame our tissues. In seabirds, for example, ingested plastics cause a newly documented condition called plasticosis, fibrotic scarring of the stomach lining. In humans, the concern is that chronic microplastic exposure could lead to similar inflammation and damage, especially in sensitive tissues like our lungs or the gut. In fact, data already shows that patients with inflammatory bowel disease, for example, have higher concentrations of microplastics in their stool, and studies have shown that more severe disease correlates with more plastics. But plastics aren't just physical objects. They are complex mixtures of polymers combined with additives like phthalates or bisphenols, such as BPA, which you've probably heard of. And because of their porous nature, they can absorb contaminants like pesticides or flame retardants, many of which are known to disrupt our hormones, damage our DNA, and harm the brain. So it is hypothesized that as microplastics accumulate, they could continuously release small amounts of these disruptors deep within our tissues. Plastics are chemical sponges, and when they enter your body, they essentially act as a slow-release capsule of toxins. Because the body recognizes these microplastics as foreign invaders, our immune system responds. But what makes microplastics different from other pollutants is that plastic is designed to last. It doesn't degrade easily, and our immune cells cannot break it down. Once it enters tissue, there's no known mechanism to fully remove it. Instead, they remain lodged there, leading to persistent inflammation, chronic immune activation, and the formation of granulomas. And as if that wasn't scary enough, there's also evidence that microplastics carry pathogens, bacteria or viruses that attach to their porous surfaces, potentially delivering these microbes deeper into the body past our defenses. Such a persistent burden might exhaust the immune system, leading to reduced ability to fight real pathogens. And long-term, this might mean higher susceptibility to infections or increased incidence of allergies or inflammatory conditions. Over the past decade, rodent studies have shown that microplastics can impact nearly every major organ system. In the lungs, inhaled fibers triggered inflammation and oxidative stress and impaired the airway's natural cleaning mechanisms. Young animals were especially vulnerable, and some developed irreversible lung damage and, in extreme cases, tumors. In the cardiovascular system, microplastics were found lodged in blood vessel walls, where they caused localized inflammation and oxidative damage to the vascular lining. And disturbingly, similar patterns have now emerged in human research. A 2024 study found that patients with microplastics embedded in their arterial plaques had a 4.5 times higher risk of heart attacks, strokes, or death over a 3-year period. The scientists can't yet claim causation, but the correlation is striking, and it closely mirrors the damage observed in animal models. And the same goes for the reproductive system. In male rodents, microplastic exposure led to reduced sperm count, poor motility, abnormal sperm morphology, and smaller testes weight. In female animals, it caused ovarian toxicity, disrupted hormone levels, and lowered egg quality, especially when plastics carried endocrine-disrupting chemicals like phthalates. And while human studies are still in very early stages, the red flags are already showing. But perhaps one of the most alarming discoveries is that microplastics can penetrate the blood-brain barrier. A 2023 study showed that when mice drank water contaminated with microplastics for only a few weeks, the particles were found in the brain tissue of every exposed mouse examined. Once in the brain, microplastics induced behavioral changes. Exposed mice showed signs of cognitive impairment and hyperreactivity reminiscent of dementia or anxiety disorders, and reductions in key brain proteins, suggesting early neurodegenerative damage. So here's the unfortunate reality. Most of these particles have only existed for a few decades, and since they don't break down in the body, if you're 30 years old today, you've likely had a lifelong low-grade exposure that is still accumulating. Scientists are now asking, what happens when these exposures continue? Again, the research on this is still very new, but experts already believe that microplastics may contribute to chronic inflammation and long-term tissue damage, immune dysfunction, possibly increasing autoimmune risk, hormonal disruption impacting fertility, metabolism, and development, neurodegeneration through inflammation in the brain, and disturbances to the gut-brain axis, and even some energistic effects, where microplastics act as carriers for toxic chemicals or drug-resistant microbes, amplifying other environmental threats. Each of these effects is biologically plausible and closely relates to what we're already seeing in animal models. So where does that leave us? Microplastics are in us, they are not inert, they are not passive, they interact with our biology on pretty much every level, and while we don't yet know everything, what we already know so far is more than enough to justify action. So in my next video, I'll explore what the body can and cannot do to eliminate microplastics once they're inside. We'll talk about detox strategies, common myths, and the most effective ways to reduce your exposure. Because while this may be the reality we've inherited, it doesn't have to be the one we accept. Thank you so much for watching, and I will see you in my next video.